You're welcome again to my channel, Mirrorset Tutor. This is the home for exam clinic. I don't know what exam that you are afraid of writing. SSC exam, NECO exam, Waec exam, JAM, post-UTME, GSSE. This is where you get solutions to all exam fever. Whatsoever you are taught here, you can bet it that it is 100% accurate and you will really understand it well. This is Mirrorset Home Tutor, SSC Exam Clinic. My name is Andrew Obanishe. Today I've brought to you a continuation of my last video, which is 2021 Physics Practical Examination question. And in my last video, we treated question 1. Today, we are going to treat question 3. I want you to subscribe to this channel so that whenever any video is posted, you can see it and take advantage of it almost immediately. Please don't just view, make sure you subscribe. It does not cost anything to click the subscribe button. Make sure you subscribe so that you can always benefit from all our videos. After the exam period, we are going to be posting many things, topics that have to do with physics, from one topic to the other, from SS1 to SS3. We're going to treat past questions. I can assure you, as long as you stay tuned to this channel, there is no lesson that you will listen to on this channel that you will not understand. If physics has been a nightmare to you before now, I tell you, you have come to the right place. Just subscribe to this channel and you can ask or make a request of any topic that is a nightmare to you or that you do not understand, and I tell you, I will break it into pieces for you, and you just know that physics is not as difficult as people have projected it. So you're welcome to Mirrorset Home Tutor. Do not forget to subscribe. Click the subscribe button now. All right, now we want to treat question 3 of the 2021 Physics Practical Examination. This is a list of the instructions material that Waec sent to schools to prepare and make available for the examination, right? The instructional materials are accumulator or 2 dry cells. An accumulator will give you 2 volts. Then you have the dry cell, one of them will give you 1.5, 2 will give you 3 volts, right? Then you have to get an ammeter. Ammeter is from 0 to 1 ampere. 0 to 1 ampere means the full scale deflection of that ammeter should be 1 ampere. And that tells you something, that in the experiment you are expected to perform, the maximum value of current that will be measured will be about 1 ampere. You're not going to have anything that is above 1 ampere. And that is very important. If you use 0 to 2 or 0 to 3 or 0 to 5 ammeter, you are going to have problem. The problem you're going to have is that you find out that when you vary change anything, maybe like the length of the consultant wire, as we see later in the course of the experiment, and you expect the current in the circuit to change, the pointer will remain at that same point because the scale is too large for it to detect any significant minute difference or change in the current. All right, so make sure you are using a 0 to 1 ampere. Then you have to get crocodile clip, a 2 ohm standard resistor, the constantan wire. The constantan wire must be 1 meter long, and that's 100 centimeter long, and you have connecting wires. Now, based on experience, I will advise that in this particular experiment that you use an accumulator, which will give you a 2 volt power supply or a 2 volt source. You know, if you use 3 volts, which is the dry cell, you will not be able to use the 0 to 1 ampere ammeter. From experience, there is no type of constantan wire that you will use that you will be able to measure current less than 1 ampere if you are using the 3 volt dry cell. So if you must use the 3 volt dry cell, then make sure your ammeter is 0 to 2 volts or is 0 to 3 volts. But if you are going to be using 0 to 1 ampere ammeter, make sure you are using an accumulator. This is based on experience, so that you will not run into any hiccup in the course of the experiment. All right? Now, this is the setup for the experiment. This is the circuit. You have the battery. From the positive terminal of the cell, a wire is connected to the positive terminal of the ammeter, and from the negative terminal of the ammeter, you have another wire connected to one end of the 2 ohms resistor. From the other end of the 2 ohm resistor, there's another wire that goes to one end of the key, and then from the other end of the key, you have another wire that goes to the negative terminal of the battery. Then there are 2 junctions. All right, there's a junction between the ammeter and the standard 2 ohm standard resistor. That is where you connect the constantan wire. Then there's another junction between the standard resistor and the key. At that junction, you also connect the crocodile clip. All right. Now that tells you something, that the constantan wire and the 2 ohms resistor are not connected in series, but they are connected in parallel. And that means that the current measured by the ammeter, the current in the circuit, is being shared by the constantan wire and the standard 2 ohms resistor. That also tells us that the potential difference across the constantan wire is the same as the potential difference across the 2 ohm standard resistor. Hence, they are both connected in parallel. All right. So usually, students run away from electricity experiment, which is the simplest experiment. It's so simple and it saves time. But they run away because of the connection. And there's nothing wrong with the connection. All these lines you are seeing in the circuit are wires. So usually I tell my students, start your connection from the positive terminal of the battery or of the cell. So from the positive terminal, you have a wire that goes to the ammeter. From the ammeter, there's another wire that goes to the resistor. From the resistor, there's another wire that goes to the key. And from the key, there's another wire that goes back to the negative terminal of the battery. Then you have 2 junctions where you connect the constantan wire and then the crocodile clip. So just follow the circuit and then use it as a guide for your own connection. Now this is a typical question that you should expect. Connect the circuit as shown in the diagram above. Close the key. Read and record the ammeter reading I0 when the crocodile clip is not in contact with the constantan wire. What it means is that after you have connected the circuit, close the key, but do not allow the crocodile clip to touch the constantan wire. Then you check the ammeter reading. You will notice that if the crocodile clip is not touching the constantan wire from the circuit, as you can see on the screen, the circuit is still complete if the key is closed. So current will still flow through the ammeter. But that time, it will be measuring the current in the circuit without the constantan wire. And that the question is asking you to record as I naught. Okay? It's as good as saying that is the current that flows through the circuit when the length of the constantan wire is 0. It's another way of putting that's another way of presenting it. All right? Now, open the key. Then with making contact with the constantan, now you can now use the constantan wire to touch. You can now use the crocodile clip to touch the constantan wire at a length L equals 80 centimeters. Don't forget, the length of the constantan wire given to you is 100 centimeters. All right, then at the 80 centimeter, you use your meter rule, because you're going to be given a meter rule. You use your meter rule to measure 80 centimeters. All right, and then at the 80 centimeter, you put the crocodile clip. Then close the key and then check the current that flows through the circuit. Record that as I. So you repeat the procedure for when the length of the crocodile of the constantan wire is 70, 60, 50, and 40 centimeters. In each case, determine the current that flows through the circuit. All right. Now there is something that I will explain to you later concerning the readings you should expect when you are measuring your current with the ammeter. So in each case, take the ammeter reading and then evaluate inverse of L. Tabulate your readings. Then you have to plot the graph of I on the vertical axis, then inverse of L on the horizontal axis, starting both axes from the origin 0, 0. What this means is that you will start your scale of the axis from 0 for both axes. All right? So you are not permitted to match your points. All right? No matter the figure you have in your table, on the vertical axis, make sure your scale starts from 0. On the horizontal axis, make sure your scale starts from a 0. This doesn't mean that your graph is going to pass through the origin. Because as I will show you later, in this particular experiment, there is going to be intercepts. All right? There will be intercepts, meaning that your straight line graph will not pass through the origin. So when the question is telling you starting both axes from the origin 0, 0, it's not telling you the graph is going to pass through the origin. No. What it's telling you is that when you scale your graph on the vertical axis, start from 0. When you scale your graph on the horizontal axis, start from 0. Then determine the slope S of the graph, determine the intercept on the vertical axis, and then evaluate P, where P is the intercept over the slope. Now, this is how your table, your composite table of observation should look like. All right? All varying values are expected to appear in your composite table. What do I mean by varying values? Your length, the length of the constantan wire is a varying value because you are changing the value or the length of the constantan wire. And as you change the length of the constantan wire, the current that flows through the circuit changes. So the current is also a varying value. Then inverse of L is also a varying value because as you vary the length of the constantan wire, the inverse of that length is also varying. All right. So any value that changes in the course of the experiment is expected to appear in your composite table. That is very important. Your I naught do not need to appear because you only took the reading for I naught once. It's not a repeated value. It's not a recurring value. So it's not, the value is not changing. We can say it's a constant. Therefore, it's not expected to be in your composite table. You can just write it somewhere at the top of your composite table. Exactly. All right, so your table of values is supposed to look like this. And there's something I want to call your attention to. In physics practical, whenever we are marking, there is what we call trend. And that is very important. What do we mean by trend? Right? If a value is increasing, then the corresponding value, does it increase or reduce? That is what we call trend. If a value is reducing, the corresponding value, does it increase or reduce? That is what we call trend. And that trend also determines how your graph will look like. So, in this particular experiment, you will recall that the Constantine wire and the standard resistor are connected in parallel. Alright? Now, if you increase the length of the Constantine wire, you are increasing the resistance. Remember, the resistance of a conductor is directly proportional to the length of that conductor. So if the length of a conductor increases, the resistance also increases. So if the length reduces, the resistance also reduces. All right? Now, the Constantine wire is connected in parallel to the 2 ohm standard resistor. Okay. Now, if you reduce the length of the Constantine wire, the resistance of the Constantine wire will also reduce. And if the resistance of the Constantine wire reduces, it means the equivalent resistance in the circuit will also reduce. Therefore, you should expect the current in the circuit to increase, since the resultant resistance is reducing. Okay, so this is the reason why, as you reduce the length of the Constantine wire, the highest value of the lowest value of current you will have will be the one that corresponds to 80 centimeter length of the Constantine wire. So meaning that you will have your highest value of current when the length of the Constantine wire is 40 centimeters. And that tells us that as the length of the Constantine wire reduces, the current in the circuit increases. Now, this is just a typical experiment. It's not the exact question. But whatever you are going to be given is not going to be different from these. There will only be little variation. What are those variations? For example, instead of reducing the length of the Constantine wire, you can be increasing the length. The question can ask you to start from 40, 50, 60, 70, 80. That is, instead of reducing the length, you may have to now increase the length. So if you are increasing the length from 40 to 80, it means as the length is increasing, the resistance is increasing, and then you should expect your current to reduce. This is what we call trend. So don't just take this hook, line, and sinker. It's just for you to understand how to perform the experiment, and there can be various manipulations, but whatever is the manipulation, the experiment itself is the same procedure. All right? So just for you to understand that the length can either be reducing or increasing. If the length of the Constantine wire is reducing, the current in the circuit will be increasing. If the length of the Constantine wire is increasing, the current in the circuit will be reducing. Exactly. Now, so this is a composite table, or how it look like. Now, in this particular experiment, the question is asking you to plot the graph of I on the vertical axis and then L inverse on horizontal axis. This can be reversed. Alright? The question can decide to ask you to plot inverse of L on the vertical axis and I on the horizontal axis. If you know how to plot graph, regardless of whatever you are asked to plot on the vertical and on the horizontal, it makes no difference. What is important is for you to carry out the experiment accurately and get your values correctly. Your table of observation, make sure you get it correctly. Once that is done and you know how to plot graph, it does not matter what you are asked to plot. It will not be a problem. All right? You can even be asked to evaluate inverse of I. And then you can be asked to plot inverse of I on the vertical axis and L on the horizontal axis. All right? Now, so your graph is expected to look like this if you are plotting I against inverse of L. Now, these are the precautions for this experiment. Do not forget to present your precautions in the right language. That is very important. And what is the right language? You are expected to personalize the precaution because you performed the experiment. And you are expected to present it in past tense because you have done the experiment before writing the precaution. Precaution is just to tell us what you did or what you didn't do to ensure that your experiment is accurate, or you get that to ensure that you got the accurate result. So these are expected precautions for this particular experiment. I ensured the terminals were tightly connected. I personalized, ensured past tense. I ensured the terminals were tightly connected. I ensured the plug key was removed after each reading so that the battery will not run down quickly.